Continuing on Module 7, Lesson 8, we're on page 2. We had just figured out at the end of the last video that the pattern was add 4 on this one. So when we add 4, we get a 2, 6, 8, 12. Oh my, I didn't do good, did I? I said 6 and I wrote 4. Yikes. It's not good. So add 4, we get 2, add 4, we get 6, add 4, we get 10, add 4, we get 14, add 4, we get 18. So let's check and see. 4 times 5 minus 2, 20 minus 2, 18. Yep, looks good. Okay, so same question as before. What is the point in common? So negative 2. No, that one doesn't have the same. No, 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 no. Oh, man. So what do you think? There wasn't a point in common. Because the lines are what? Parallel. We knew that from the very beginning. The slopes are the same. We learned the lines are parallel. Why? If none, then why? The lines are parallel whenever the slopes are the same. And parallel lines never intersect. So that is why there is no point in common. Slopes are the same, the lines are parallel, and to have a point in common, the lines have to intersect. In parallel lines, the points do not the lines do not intersect. That's why there's no point in common. So now let's see what that looks like graphically. So we had first the red line, y equals 4x plus 1. And then we had the purple line, y equals 4x minus 2. So the y-intercept on the purple line was 0, negative 2. And the rise over run, which is a slope, would be 4 over 1. And same thing here, y-intercept 0, 1. And the rise over run is 4 over 1. So let's go ahead and graph those. We'll start with the red one. So 0, 1 for the y-intercept. Rise 4, run 1, 1, 2, 3, 4, run 1, 1, 2, 3, 4, run 1. And then if we want to go backwards, we can do down 1, 2, 3, 4, and run back 1. Oops, 2, 3, 4, back 1. And since we already know they're not going to cross, I'm not going to put any more on there. Guess we could have made a mistake up above, but we know that because the slopes are the same, they're not going to cross. So next we have 0, negative 2 for the y-intercept. Rise 1, 2, 3, 4, run 1. Rise 1, 2, 3, 4, run 1. Rise 1, 2, 3, 4, run 1. So they are indeed parallel. So That's called solving by graphing. So we would write no solution for our solution. And that's because lines are parallel, which means they have no points in common. Okay, last, we are going to solve algebraically. So we have y equals 4x plus 1 and y equals 4x minus 2. So again, to use substitution method, we say two things that are equal to the same thing must be equal to each other. So we used y equals y in our last packet. So this y we're going to replace with 4x plus 1, bring down our equal sign, and this y we're going to replace with 4x minus 2. And then when we go to bring our x's to the left, that's when we see, oh, this is going to be one of our special cases because the x's cancel on the left and they cancel on the right. And remember how to tell whether this is all real numbers or infinite solutions or whether it is no solution. We have to bring down the next line. 1 equals -2. Because it is a false statement, that's how we know to write no solution. But had it been a true statement, 1 equals 1, -2 equals -2, then we would have written infinite solutions. There we go. So 3 different ways and the same answer each time. No solution, no solution, no solution. Okay, let's move on to page 3. Find the break-even point. Do you guys remember talking about that in one of our past sections? The break-even point is when a company has not made any money. So they've paid their expenses, but they haven't made any money. The break-even point occurs when what you've brought in equals your costs. So you don't have any profit yet. Your revenue equals your cost, but there's no profit. So it's called break even because it's what you needed to sell. Like I think on that activity we were doing, we had to sell 4 computers in order to break even. Anything after 4 computers, then we made a profit. Because there's costs like, the rental of the building that you're in, paying your employees, electricity. So your first few computers or whatever it is you're selling are going to go towards that, and then after a certain number, then you start making a profit. So break even from that computer problem, which was a couple lessons ago, means your revenue, what you've brought in, equals your cost. So you haven't made a profit because in order to make a profit, it's your revenue minus your cost would be a profit. So if you had some left over. So the revenue, the money you brought in, equals what you paid out to your employees and rent. So break even. Haven't made any money, but you're not in the hole. So we will use substitution method, I think, because R of X is 25x plus 15,000. And bring down your equal sign. In place of C of X, we're going to substitute the cost function, which is 85x. And then we just have a simple little algebra equation to solve. So let's just write revenue equals cost, just so you kind of get that stuck in your head. So that's called the break-even point, when revenue equals cost. So when your revenue is more than your cost, then you have a profit. When they're equal, it's break even. Well, since our constant's already over there, let's go ahead and bring our x to the right. So we have 15,000 equals 60x. So divide by both sides by what's in front of x, 60. And so then we have 15,000 divided by 60. 5000 divided by 60, 250. So now we need to read the problem so we know 250 what? Use a revenue. I guess they never told us. So it's just 250. So it says find the break-even point. So we have to sell 250. And how are we going to tell what that gives us? Look what it says. X equals 250. Don't we have two equations up there we can plug it into? And remember, we always want to plug it into both because that's our check. So let's put it in here. So R of 250 equals 25. In place of X, put 250 plus 15,000. So let's see what the revenue is. So 25 times 250 plus 15,000. That gives us $21,250. So once we've made 21,000, we've paid off all the supplies, all the rent, all the employee. After anything we make over 21,250 is in a profit. So if we've done it correctly, though, remember when we plug it in here, we should get the same answer. So let's see. So the cost of producing 250 items is 85 times 250. So here's the moment of reckoning. Are we going to get the same answer? 85 times 250. Ding, 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 ding. Same number. Woohoo! So our costs are going to be 21,250 and our revenue is going to be 21,250. Once we sell more than that, then it's a profit. So that's going to be our Y, 21,250. So this is how many items you would have to sell. And this is your revenue or your cost, because we just showed that they're the same, right? So if we sell 250 items, we have a revenue of this and a cost of this. Therefore, we have broke even. We might as well put that $sign because we know revenue is going to be dollars. Okay, so now they want us to interpret the meaning of our solution. If I sell 250 items, both my revenue and my cost will be 21,250, which means I have broke even. Both my revenue and cost will be $21,250. So I will break even. So sell 250 items. The revenue and the cost, as we showed above, will both be 21,250, which means I have broke even. I've